Okay, so howdy everyone. My name is Jay McCarthy. I'm the CTO of Reach, and Reach is a programming language that is designed to allow you to program a dApp. And unlike what you may have heard about of other blockchain programming languages like Solidity and whatnot, it is designed to program the entire dApp rather than only the smart contract. Also on the call with us, we have BB. BB, will you unmute and just say something real fast?
Yes. Hello, everybody. I'm BB. I work with Jay at Reach, and I am one of the many developer relations engineers. So I will be helping answer some of your questions in the Discord channel.
And then we also have Matt, who is on the call as well.
Hey, everybody. I'm Matt. I work with Jay and BB. Glad to help out. Thanks.
Great. So BB and Matt will be, hanging out in the Discord, helping you if you have any questions. And what my goal is today is, as was mentioned, the presentation time will be kind of limited, like 20, 30 minutes or so. And so I won't be able to explain everything, but the way that we've designed the Reach tutorials is really designed for you to be able to go through it yourself on your own, potentially with support on the side. If we were to do the whole presentation ourselves, then we've done it before in 3 2-hour sessions. You know what I mean? So we're not going to be able to do everything, but I kind of want to give you a brief idea of what is going on in Reach, and to sort of get you oriented towards starting building your first dApp. So what I've got right here loaded is the Reach documentation site, which is docs.reach.sh. And the intro page basically tells you that there are 4 things that you might want to look at. You can look at what we call the overview, which is a brief description of what Reach is. The tutorial, that's what we'll be focusing on. The guide, which basically explains why and how and what exactly is going on with Reach. This is sort of like the Wikipedia of Reach. It's there for curiosity, but you don't really need to go look at it. There are workshops, and workshops are basically projects that you could work on after you've established the foundation. This is what I recommend that you'll be working on in the future. And then the reference, which is basically an exhaustive list of every function, every syntactic form, all of those things. But today we'll be looking at the tutorial. So let's click on tutorial. The tutorial is broken down into some really very small steps. So the first thing that you're going to want to do is install, and I hope that Pierre Giacomo has sent out something beforehand so you can go through the install process. I'm using Windows, and on Windows it's just a little bit painful because basically the best way to do it is to use WSL, which hopefully you're already doing because WSL is pretty great. But if you're on OS 10 or Linux, then you're probably already. The main thing that you want to have is you want to have Docker installed. So what I'm going to do right now is I'm going to make a directory in my home directory called Reach tutorial, and then I'm going to go into that directory. And then I'm going to install Reach. So I'm just going to copy this. Whoops, I don't want that. No, that's not the one. I pressed the wrong button. I entered a debug mode. There we go. I want to copy, and then there we go. Okay, so now I've got Reach installed, and so I can make sure that it's available by writing compile version, and then it'll say that okay, it's really running. You can run Reach update and it will download the latest images if they're there. Reach is a fully Dockerized application, so when you install it, you're just installing a really small shell script, and then it will go off and get Docker images that run all the components of Reach. Those components of Reach are the compiler, and then devnets, which are basically little hermetically sealed off versions of all of the consensus networks that we support, so that you don't have to run some other tool. You don't have to manage it yourself. You don't have to connect to the live network, anything like that. Now, when you write a Reach program, what you're doing is you're going to be writing a file in the RSH format. And basically it's a variant of JavaScript. Let me just open up right now. So I use Vim, but you can use any editor that you want. If you use VS Code, then there is an IDE plugin that provides syntax highlighting, things like that. If you're not using VS Code and or if you're not going to install that thing, basically what you want to do is you want to just set your editor to treat Reach files as JavaScript. So anyways, when we write a Reach program, we're literally writing in JavaScript, but we're writing in kind of a version of JavaScript that has some unique ideas in it related to blockchain programs. It's almost like we're writing a it's almost like we're writing using a library for blockchain stuff, where what we're doing is we're constructing a dApp. And I've sort of provided right here the shell of what a Reach program looks like. And I just want to sort of highlight just a few things. It might seem like I'm going in detail through the tutorial, but we're about to skip ahead really fast. So what I've got right here is, like I said, we're making a JavaScript program and we're defining a Reach application. And then one of the main ideas about Reach that is different from other blockchain programming languages, as I mentioned before, in it you program an entire dApp. What does it mean, an entire dApp? Well, let's step back a moment. Nobody wants to download executables. No one walks around saying, I wish I had an executable. I wish I had an executable. They want an application that does something. And an executable is the way that they get it. And so similarly, Reach's perspective is that people want applications, and smart contracts are just sort of an implementation detail about how they work. And what do people want to do with their applications? Well, they have certain workflows, or you might use the word business logic to refer to what they're doing. So for instance, if we're talking about something like a buy-sell order, then we want to have the workflow of someone puts up something that they want to sell, and someone sees it and comes along and buys it. And so we can describe the application of a sell order by focusing on the individuals that carry out the application. And then from that, a sufficiently smart compiler could figure out what the individual participants should do and what the smart contract should be that actually enforces those rules. And that sufficiently smart compiler is exactly what Reach is. What it does is it takes a description of what the individual endpoints are in a program, and then from that description, it derives the smart contract and all of those pieces. So what that means is that the main components of a Reach program are first specifying who it involves. And we typically use the security common names, Alice and Bob. And then after specifying who is involved, we specify what happens. And we're specifying what the individual participants do. Now, once we do that, what Reach does is it will take this program, so I can write Reach compile, and what it's going to do is it's going to produce the smart contract. It's going to produce individual clients that will run your program, and it also does verification, which it printed out here. These outputs are in a directory called build, and it outputs it as JavaScript. And so what this means is that you get to write your program in JavaScript, and you get to interact with it in JavaScript too. So I'm going to make another window right here, and I'm going to open up a new file that is going to be a JavaScript program. Now what this program is going to do, and I'm actually going to copy and paste a little bit, and the reason I'm going to copy and paste is because I was just working on something and my hand really hurts and I don't want to type it out. Okay, so I'm going to copy and paste this right here. And what we're doing is we import the Reach standard library. We import the code that got generated by the compiler. And then what we're going to do here is we're going to write down some test code that will automatically interact with this program. The first thing that it's going to do is it's going to create completely autonomous test accounts. because this is going to run on a fake DevNet. Then it's going to have Alice deploy the application and Bob attach to it. This deploy and attach are like unique reach concepts. They essentially correspond to, like, you might think of it as like launching a server and then connecting to that server, except of course that there is no server because it's run on the consensus network. And then in JavaScript, there's no way to have like multiple threads. So multiple threads are simulated by what are called promises. So essentially what the rest of this program does is it says, start a thread for Alice and start a thread for Bob. Now notice what we're doing is we're calling backend.alice. So this backend.alice is a function that we imported from the compiled reach program. Essentially what it is it is the part of the reach program that only involves Alice, and backend.bob is the part of the reach program that only involves Bob. You can kind of think of it as like, when you write down your program, you're specifying the entire computation all at once, the things that Alice does, the thing that Bob does. And one of the things that the reach compiler does is it separates these two programs and makes them individual things where, you know, when Alice sends something, Bob receives it. When Bob sends something, Alice receives it. In these programs, they communicate with one another by an intermediary, which is the consensus network. Okay, now this right here is basically like the structure of a very simple program, but of course it doesn't do anything. What the tutorial does from this point is it walks you through building a wager-based game of rock, paper, scissors. Now I want to explain just a little bit of why we do this. Probably you've already heard of the game of rock, paper, scissors. And because you've already heard of that game, I don't need to explain to you all of the intricate rules about how rock, paper, scissors work. Instead, I can focus our teaching time on how to make a decentralized program that is a game of rock, paper, scissors. In contrast, if I wanted to teach you about dApp development, and I said that we're going to write a DAO or an automatic market maker, or we're going to make a stable coin, those are all very popular ideas that people are extremely excited about building dApps for. But if I go downstairs and I talk to my son who's in, middle school working on basic computer science, he knows what rock, paper, scissors is. I could probably teach him Reach, but he has no idea what stable coins are, what DAOs are, why they're important, what the economics of them are. So basically, when we enter the dApp world, there's this complicated domain of crypto economics, essentially. And then there's another domain of programming in this interesting world. And Reach, our goal is to teach you programming in this world without forcing you to also at the same time learn about crypto economics. Because maybe you're not interested in that. Maybe you have some totally different idea, or maybe you are interested in that, but at least now what we can do is we can teach you one thing and then the other thing separately from one another, so you don't have to do both at the same time. So that's the motivation for using rock, paper, scissors. I'm now going to switch and sort of show you a little bit inside of the web browser. What I recommend doing after I'm done talking is you're going to go through this yourself, and I just want to kind of give you a flavor of what you're going to see. The first part of the tutorial walks through just having the rules of the game enforced by the smart contract, where what Alice will do is she is going to figure out what hand she wants to play. Then Bob is going to figure out what hand he wants to play. And then we're going to figure out who the winner is. And because both of these values will be sent on the consensus network, that means that everybody will consensually agree to those values having actually been the values that were published. The key goal of consensus networks is to reach consensus, which means for everybody to agree on what happened in the past. Clearly, you can see why this is a very important concept for something like spending money. We want everybody to agree that, BB has spent the money and that I'm the one who received it. Although actually in our relationship, the money typically goes in the other direction. So the goal of consensus networks is to figure out what everybody should agree on. That's kind of the first point. And in this case, we do that with the very simple problem of verifying that Alice really played rock and Bob really played paper. Now, what we do in the next one is we up the ante, so to speak, by making it so that Alice not only is going to propose a hand that she's going to play, but she also is going to say, I'm going to bet you 5 ETH for this. Now, of course, 5 ETH is a lot of money. Alice is a high roller, but this is a high stakes game of rock, paper, scissors. So she's going to bet 5 ETH, and Bob is going to bet 5 ETH, and that means that whoever wins is going to get 10 ETH, minus, of course, the gas fees. And so what we're doing here is we're introducing kind of the next idea about DApp programming, which is that the real reason that you make a DApp is because you want to have some scarce resource that whose ownership is enforced by the program. In this case, the scarce resource is the ETH or the algo or something like that. I just realized now that I've never actually mentioned that when you run a Reach program, you actually compile it for many different consensus networks. We support Ethereum, we support Algorand, we support a few other EVM-based chains as well. And in the future, we have plans to support many other networks. So anyway, so the reason you write a DApp is because your program needs to enforce the safe management of some scarce resource like the tokens. But of course, there are many other kinds of scarce resources that are worth taking care of too. A lot of these are represented right now by things like NFTs. And this is kind of the thing that makes blockchain exciting because historically, there hasn't been a trustless way of managing resources like that. And that's really what makes blockchain special. Now, after writing this program, one of the things that we do in the next chapter is we talk about how it turns out that the program that we wrote before has a major flaw. And its major flaw is that it accidentally exposes information that should have been secret. And here we introduce a very common DApp programming pattern called the cryptographic commitment. The cryptographic commitment essentially makes it so that I say something, and then that makes it so that I can't take my word back, but BB doesn't know what I said. And then BB can do something, and then I can reveal what I said, and BB can find out if I am changing my mind. In this case, what it's applied to is Alice is going to choose what hand she plays, but we don't want BB to know, we don't want Bob, we don't want Bob to know what hand he played, or sorry, Alice played, because then he could just always win. So Alice has to commit to her hand, Bob will pick his, and then Alice will reveal. And this is an extremely common pattern. And what's really nice is that it actually shows up in this simple game like rock, paper, scissors. My guess is that if you've studied dApps at all, you will have seen this commitment pattern show up. And it's nice that it shows up in this situation. Now, from here, we go on to kind of the next big idea that's special about dApp programming. And that's this concept called non-participation. In normal programs, of course, someone could just walk away from the program. So imagine that, I'm playing Overwatch with somebody. Someone could just like walk away. I remember there's this very annoying fight in Demon Souls where where some other person controls this boss, and I was terrible at the game. Or at least I was good enough in the environment people, but I wasn't good enough for this. So I remember that I unplugged my PlayStation when I played that fight. So I just walked away from the game in that case. So in normal client server programs, people can walk away all the time. But in normal programs, when you walk away, you're not leaving, $20,000 of ETH in your rock, paper, scissors contract. And so because of that, there's this really fundamental concept that, again, shows up in lots of dApps that is called timeout and non-participation. So the idea here is that we detect when someone isn't going to play, and then we punish them for not playing by taking back their resources. And so Reach integrates into it at kind of a fundamental level, the handling of these kinds of timeouts. Finally, the next thing that we do is we talk about making programs that take arbitrarily long, because up to this point in the tutorial, all of the programs have been very, very short, but of course, real interesting programs run forever. like Zoom, for instance. I guess actually Zoom is kind of a bad example because by default, Zoom will turn off after 45 minutes. But most programs, their goal is to basically run forever. And so it's very common in dApps as well. And so that's what kind of goes on here. Now, I've basically explained in, 20 minutes or so what you're gonna learn. But of course, you haven't learned it yet. But the culmination of this is that you'll have a relatively svelte reach program, which will clock in around at like 50 lines or so. And then you'll have a JavaScript driver program, which is like an automated test suite for it. It's like another 50 lines of code. And those 100 lines of code that you'll work together, behind the scenes, the Reach compiler is going to produce like thousands of lines of Solidity and backend middleware code to interact with the actual consensus network SDKs, and thousands of lines of Teal code. Teal is it's like the virtual machine language for the Algorand network. So it's going to produce all the stuff that you don't need to, so you can think about your program at this very, very high level. And when you do that, you'll then be able to focus on the business logic that you care about. And one of the things that the tutorial also does is it walks you through building like an interactive terminal version of the game, as well as a web-based version of the game that's based on React. And I think that's one of the reasons why you're going to get a lot of value from going to the workshop next week, next Tuesday, that is focused on learning React. Now that's kind of a summary of where you're going to go. What I hope that you will do right now is maybe there will be a few questions that I can answer. And then I hope that you'll all, go back to step 1 of the tutorial and start working through it. And BB and Matt will be around to, give you any advice or pointers as you go. Does that match your expectations, guys? And any questions? What time will the next workshop be at? There was a slide at the very beginning. I believe it was next Tuesday at the same time. Any other questions? I mean, that's kind of a organizational question.
I think we can take them to Discord and
Okay.
Have people play around a little bit. Maybe one takeaway, Jay, about like what else can you build in terms of like business application?
Oh yeah.
Maybe
this
people
is a good point.
don't really know like what are exactly. So maybe if you can spend a couple of minutes on that.
Yeah, thanks for keeping me honest. I sort of took for granted that you might want to try to learn to do this. And as I mentioned before, nobody cares about rock, paper, scissors. The thing that's special about it is that people already know what it is. But of course, people are not starting the, rock, paper, scissors incorporated. What people are actually doing is they're building these other things I mentioned before, like DAOs, stablecoins, etc. And Reach has a large repository of example programs that are the kinds of exciting programs that people want to build. And so this is what this whole workshop thing that I mentioned before is. So the workshops are basically a way of us sort of saying, you should try to write this program. And by trying to write this program, you'll learn about a dApp concept. And each one of these workshops will say something like, here, I'll go to this one. So the relay says that, in this workshop, you're going to learn about how to transfer funds to somebody that you don't know who they are right away. And this is sort of like a representation of like a gift card. And so how it works is it sort of walks you through like, what is the goal of this program and how would you design doing it and that kind of thing. Now, some of the workshops are sketches where we only specified the problem, and then we have a link to some code where one of the Reach engineers has already written this program, and we intend in the future to write a full tutorial on it. So if you think of something like an atomic swap, this is basically like the core component of what is called a DEX, a decentralized exchange. Because basically what stock exchanges are doing and what currency exchanges are doing is they're connecting buyers and sellers. And what an atomic swap is essentially a seller being able to post their fund saying, I'm willing to sell this. And nowadays, of course, people are more excited about liquidity pooling swap pools. But sort of like the fundamental component is something like an atomic swap. Another example would be something like, a raffle. So we have like an example raffle program. So these are the kinds of things that people build in practice, and all of these things can be built in Reach, and typically at vastly smaller sizes and with less effort than using the underlying tools directly. So one of our favorite examples that we'd like to talk about is Uniswap. So Uniswap is, of course, a very popular program, and it's pretty big. If you were to go look at the Solidity code, it's like it's on the order of like 500 lines of code, plus it has this big library that it uses. So maybe it's like 2,000 lines of code. And one of our engineers, actually, someone who we hired him, he'd never heard of blockchain before, taught him Reach, told him what Uniswap was, and he was able to recreate Uniswap in Reach in about like the first month of him joining the company. And it took him maybe like a week to actually write the program. And I'm kind of sort of saying this in a very nonchalant way, but this is pretty amazing because it's very difficult to locate people who can become dApp developers who can build a project on the scale of Uniswap. And what Reach is doing is it's drastically raising the level of abstraction for dApp design so that people can get into it much faster. I kind of think of the goal of Reach as making it so that we are simultaneously lowering the floor of development, so you don't have to start so high when you get started, and increasing the ceiling of dApp development because you can make programs that are more complicated than you would have been able to do had you been using the low-level tools that the rest of the space uses. So, yeah. So rest assured that pretty much everything that you would want to do can be done in Reach, and many of the popular programs have already been done. And one of the things that we kind of believe as a company is that blockchain is much bigger than the 5 programs that people write now. I think that there are going to be way more interesting blockchain programs than just, DAOs, DEXs, NFTs, and swap pools. And so because I think that there's going to be much bigger programs than these, many more programs than these, I want to create an environment where people can experiment creatively with lots of different programs, as opposed to having to stress and meticulously design the perfect way to do one of these 5 ideas.
Awesome. And it's also worth mentioning maybe that like Uniswap was, kind of like copied and just rebranded with like Sushi Swap, for example. And, people kind of like tweak the code around a little bit and created other liquidity pools that grew in like a matter of months to like billions of dollars locked. So if we can make that easier, that's even better.
Yeah, I think that it would be wonderful to be able to spur a lot of innovation and creativity in this space. And I think it's kind of sad that people just are forking and making very small tweaks rather than really broadening their horizons about what's possible. But I'm excited about your participation in this workshop, and we're here to help you learn, and we're excited to see your progress and what you'll be able to build over this period of time.